In this case, the main idea was to create a pill dispenser that will make it easier for people to manage multiple chronic conditions. For this project, we tried to focus on older adults who may have multiple treatments with pills. As we know, the average life expectancy of people over the age of 65 has increased significantly in recent years, from 509.7 billion in 2010 to 904.6 billion in 2020. For the same reason, we believe that a lot of people could need devices that help them to stay healthy.
And well, for this project, many different components have been used, including a LED, a 7-segment display, an infrared sensor, a servo motor, 2 different breadboards, an LDR, jumpers, and an Arduino. The operation of this project is quite simple. You have a container that is filled with pills and the LDR is used as a clock. Every time you reach a certain specific lighting in the day, the LED will turn on, indicating that it is time to take the pills, and once the button is pressed, the pill will come out and the gate will close thanks to the infrared sensor. The button only works if the LED is on, indicating that the amount of light is optimal and will only work once per day. There will have to be a change of light for it to work again. Also, if the infrared sensor does not detect that a pill has passed it, will continue to open the doors until it does. The 7-segment display is used to number the current day of the week. It goes from 1 to 7, and once it reaches 7, it will restart and the number of weeks that have passed will appear in the serial monitor.
So for the code, what we have here first are the variables of each one of the elements and different variables for the states, also for the light. We have variables as counters and well, the number of medicine and the weeks that we are going to have. Also we have a variable for the servo. In a voice setup, we declare each one of the elements as inputs or outputs. We also start the serial monitor. And then we have 9 functions that are going to help us with our 7-segment displays. Each one of the functions allow us to display a different number. In this case, it's from 0 to 7. And as you can see, is an analog configuration that we have on our display. In the while loop, what we start is with reading the states of the button and the infrared sensor as they are inputs. Then we also read the state of the light that we are going to have in our room, and we display that information in the serial monitor. And then we start with the medicine system. In this case, we're going to divide in different if conditionals. We start with defining the level of light which we want the user to take the medicine. So we are saying that is between 700 and 800. And to allow the user to know if they can take the medicine, we start with turning on the LED. Then we have conditionals for the buttons and the infrared sensor. So first we make a conditional for the state of the button, and if the button is pressed and it hasn't been pressed before, then the gate is going to be open, the servo. And we allow the counter to know that we already pressed the button. So for the next conditional, we are going to be using the infrared sensor. So we are saying that if the infrared sensor is detecting something when the button has already been pressed and the infrared sensor hasn't detected anything before, then we can allow the counter to know that we already detect something, and we can increase by 1 the number of medicines. But if the infrared sensor is not detecting something when the button is pressed and it hasn't been detecting anything, then we open the gate again so the pills can pass. And if we know that the button has already pressed and the infrared sensor has already detected something, then we can turn off the LED because we know that the user take the medicine. And if we are not in the period of the day that we want the user to take the medicine, then the LED is going to be turned off and we are going to reset the variables of the counter so we can start the process again. Then we have a zero print to print the number of weeks that the user has been taking the medicine. And to define the number of weeks, we use another if conditional for the 7-segment display with the number of medicines. In this case, each number has its own function. And we are saying that when we arrive to 7 medicines, then the number of medicines are going to reset to 1, and we are going to add 1 to the week.
For the creation of our 3D design, we used the tool learned in class Onshape, where we were able to design each part separately, starting with the base, then the pieces like the tube, and finally each electronic component. In the end, with an assembly tool, we unify all the components, aiming for a result as precise as possible to achieve a result similar to our model.
In conclusion, we believe that this prototype could help a lot of people for the fact that life expectancy has increased so much. This prototype will not solve the problem at all, but it will help some people and be a start for a better product. We think it was a really interesting project to develop for the fact that we care a lot about the design and functionality in a minimalist way.
During this last project, I learned many things, especially about 3D design. I think it was one of the topics that interests me the most and from which I learned a lot. I was able to learn more on my own about the Onshape platform, which helped improve our work. The project was complicated, but my team managed to solve the problems.
So my main contribution in this project was the development of the code. One of the main things that I learned was the use of 2 counters in the creation of a system and the use of if conditionals with these counters. So what I liked the most about the project was the prototyping, and the creation of the code was something that I really enjoyed. And one of the most challenging situations that we faced was that I wasn't able to go to school because of health situation. So the development of the code was totally online. So that was like our main challenge that we have to face.
Well, my main contribution in this project was the creation of the model and the electronic part, and all this unified in an only prototype. And for this project, I learned how to connect and create all this prototype in a minimalist way and keep the functionality and the practical used. And for me, the most challenging part was the functionality of the components with the code, because Cassis was not able to be with us creating the project. So it was a little bit difficult with that, but we managed to create a really good project. And the part that I liked the most was the creation of the model, because I really like it to design it and create it.